Okay, so I don't know whether this hour won't be spoiled by this coming late all the time. If she insists that she has to make you come after the top of the hour. I thought it was common sense that when it reaches time, you should feel very happy and know that you are entering somebody's business. I don't. Have I ever gone to, I've talked to you how many courses? 2 so far. 2 complete courses. Have I ever stretched a minute into the other lecture? No. Why should I? But I have no problem. Do you have the lecture at 7?
Yes.
Which one?
You make enemies.
2 or 1?
2.
That is not there. The way you first have to think, then it is not there. So I will always compensate. But 3 hours I will be already tired also. So we start from the first bit of the lecture now, so that because last time I think I completed the outline, the revision, whether revision or repeat of the outline. I didn't have enough time to deep stuff of the things, but so we now on the introduction of the transducers, input and output transducers, passive and active transducers. So we start with today's lecture. So we start with radiation transducers, and that is lecture 1 in way. So I'll summarize, and then you can make your full notes in your free time from there. And today we should be able to define transducers. Then we discuss the radiation transducers. We look at the phototubes, the photomultipliers, the photodiodes, the phototransistors. Photo for light. So photo there is an element of light. So when we say the photodiode, it means that the diode that is responding to the photons, which are for light. The phototubes, the same. It's a tube, but responding to the photons. Photomultiplier, then phototransistor, then photoconductivity cells, and then photovoltaics. The photovoltaic cell, I have not brought I have it broke, but I have a solar cell, the smallest, which we use to make a panel. And then we look at the LEDs, the LCDs, the liquid crystal display, the bolometers, and then the thermocouples. And of course, in this lecture, I hope at the end of the lecture you'll be able to define the transducer, be able to explain the working of the photodetectors, e.g. phototube, photomultiplier, photodiode, phototransistor, photoconductivity cell, photovoltaic cell. And be able to name applications of these detectors, explain the working of the lead diodes and liquid crystal displays, photovoltaic cell, bolometer and thermocouples, and then name applications of LEDs, LCD, and photovoltaic cells. Really, you can't fail to, even if we haven't done this lecture, you can't fail to give me applications of light emitting diodes. We did that in electronics. We are using them as lamps. We are using them as indicators to indicate that that something is on or is off. We are using them in displays, in TVs. That's why currently flat TVs are called LED TVs because of the light emitting diode. So transducers in general are used in a wide range of measuring instruments and a variety of other uses in the electroacoustic field, gramophone. Anyone of you doing petroleum? The petroleum students are supposed to do this course, but I'm keeping quiet because I don't want many to do it.
Like today, I've led TVs.
Yes.
Yes, and then it was like there are multiple outlets, right?
I hope so.
Yes. Yes.
Yeah.
Now, yeah. Okay, I've noticed on buildings. Now, for example, if I give you another name, like it lights. Yeah, made up of the lids. You realize that at some, even at the petrol stations, you realize that some numbers sometimes when the lids blow, those numbers are not displayed. So is there a possibility at one point that when I have my LED TV, a given region
There are some.
will black out and then this other part is also still.
There are some TV, okay, not TV. LED displays are mostly like those of WWE, like those wrestling shows. Those screens at the ring, around the ring. Even there's other four, how do they call them? When the commentators are, when someone is hit on it, I don't remember, but those poles.
Okay.
No, bulkhead is the guard around the whatever, but these other four, this for WWE there are four, but I think for this other EW something, there are I think 6 or it's like a hexagon. But the 4 ones, even themselves, you find that smack downwards are being displayed, even on the sides of the whatever display. Then when the one runs after the other, it starts hitting him on the big wall, which is also displaying images. But you realize that sometimes a section, even in the football, those other boards around the pitch are LEDs. They are LED screens. So it is possible that one section can black out the other one. I have not really bothered to know how they are synchronized to give images. You can blame me for that, but I'll try to. By the end of this course, I should be able to explain to you how that happens. But I haven't seen a TV which is like having a section on and then another section not on. I haven't experienced that. The ones on, like on a petrol station, they are still, they are LEDs, but they are combined in segments. We shall look at it as a 7 segment, this one here. So you have these segments here, but each of them being illuminated by, or the light being given by a light emitting diode. So it's an 8 figure. Now, depending on which LED is being lit, we shall do this towards the end of the lecture. So each of these is connected to power. So if I took this to be A, B, C, D, E, F, G. So if I want a 2, for example, if I want to light 2, that means I should power A. Then I should power B, I should power E, I should power E and D. So I will be having this brighter and making it 2. So if you just make sure that it is a switch for each of the digits. So you switch on the one for 0, let's say if petrol is at 5200, you just 5, then 2, 0, 0. Then it lights those ones and the price is there. Of course, when this one kaput, then you'll be having a 2 which is just like here. And even in LCD watches, sometimes you find that problem. You find that it is one is blinking, others are stable. And then when the battery is almost getting out, you first do like this to make sure that you get the actual time. When you look closely, you see things which are just hazy. So the gramophone pickups are used by the people of exploration, oil exploration, when they are trying to find out the nature of the area any one of you doing geology, in which they are trying to do exploration. So they get a truck, and then when they get a truck, they position it somewhere, and that truck normally it's like it has some of the stands that stick on the ground, and the truck starts vibrating. So it sends out the E and S waves. Then you can plant gramophones all over to pick these waves. And now the way these waves, when you pick the signal, then you can find out, because the waves will move and be more, I don't know how to call it. They will be able to move through the strata. So if you have layers, for example, which are like these and these are, so if this is a rock and this is another rock, and then you have these as parts and that's where the oil normally is suspected to be. You find that the oil will seep through the cracks and stagnate somewhere. And that's where you find a well, where you can find a significant amount. So when they plant the gramophones, then they pick up these signals of the waves. And then they are able to plot I don't remember the exact word of these. Those of you who are doing, anyone of you doing geophysics? Okay. How do they call those things, the layers of the earth crust?
They are called beddings.
Beddings. Bedding planes. So something of the sort. So you are able to know, and depending on the nature of those planes, then you can find out that this place is susceptible to have.
That's Yeah, I do geophysics.
Pardon?
I do geophysics.
Yeah, well, I'm not interested in earthquakes. I'm using a gramophone to show how oil exploration is done. You are telling me about earthquakes. I don't care about the damn earthquakes. I am trying to show you the sensors. Then we have microphones, loudspeakers, and which are all electroacoustic transducers. Electroacoustic because when you vibrate the diaphragm of the speaker, then according to acoustics, you move the layers, you create vibration of the gas, and then eventually you produce sound. On the microphone, when I talk, like now I'm talking, I am making this air to vibrate. Remember, sound waves move and rarefactions and compressions, rarefactions and compressions, rarefactions and compressions. And so, when I talk, that is acoustics, and then the diaphragm of the microphone will be able to vibrate, and then the electronics in the microphone now takes the message into the camera, and then my voice gets recorded. So that's why we talk of electroacoustic Usos. Okay, so I will, the physical quantities, I am trying to not hard to talk a lot. The physical quantities are the things that should be able to make you understand how you choose a particular transducer, for example. So you cannot go, you want to measure the density, and then you are using a ruler. You get the idea? So you need to know the physical quantity that you want to measure, and then that gives you an idea of what sensor should I use. So the physical quantity is measured by transducers, is the measurand and the portion of the transducer which the output originates is the transduction element. And the nature of the operation is these are stuffs that you read on your own. I don't want to go into this. But in order to make a gadget, because the word instrumentation is that you want to make an instrument to do something, then you must be able to know which physical quantity you want. Is it pressure? Am I going to measure pressure? So if I want to measure pressure, I look for what is affected by pressure. Am I going to measure speed? So what is that thing that I can use to make sure that is affected by the speed? So you want to measure speed of the plane, and you are here on Earth, and you want to say, you say, I want to know how quickly it is moving, but it is there in the sky. So you have to think and know, if I, for example, I thought about like policemen, if they had sense, you would be able to know that this vehicle was speeding, because you know there is a camera on the road at one degree. There is another camera at Boise. And this guy passed at 1 degree at 12:05. He was at Boise at 12:08. The distance between them is a kilometer. So I got the time, I got the distance. I can tell you you were overspeeding and find you. That's how this woman lost her job. I wrote that the police can actually punish people by looking at how people are behaving on cameras. So she stupidly went on cameras and even picked state house vehicles, and she was sacked. This police woman who was in charge of traffic, her name was a Muslim name. So anyone of you who follows up, some huge woman.
So it's nothing crazy.
Nothing of Farida. She used to feel nice when she's giving those briefings with the Nanga. So when I suggested that they can use cameras to punish people, she didn't know that she doesn't have to bother either government vehicles or state house. If I'm driving a state house vehicle, you don't expect me to be in a jam like this. I can't. First of all, I'm an endangered species and I'm also privileged. So why should I be in a jam? So when they were overtaking careless and whatever, she collected the numbers and published them for fine. And I don't know what she does nowadays. They sacked her. The next thing, she had people who were entering her house. But it works. It would work. Those cameras would work wonders and miracles. If I was in charge of them, I just send your ticket to your doorstep. No hassle. Because your number plate gives me the phone number at URA, then I send the message with the ticket on your phone. You were driving wrongly at 1 degree at this time, at this speed, which is illegal. So you go and pay in the bank. But that's what happens in Europe. They don't hassle with you. The camera, and I think even in Rwanda it is taking place. You drive at your speed, thinking nobody is seeing you. The next time you find the ticket in your box, not where people put things. But in other countries which are reasonable, even here we could do it. When you graduate, you can make a business. You can start with Corolla and Muyenga. People where they are organized, all these small estates. You go there, you spend money, give each one of them a box, give them numbers, and say we shall be distributing newspapers and we shall be putting in your boxes. Once you are trusted and you are doing it professionally, people now start sending letters, and even these people of the markets now will start saying we can now use you to deliver merchandise, and you become stinking rich. But some fool will start supplying things which are bad, so lands your company in trouble. So radiation transducers use parts of the electromagnetic spectrum as the input or output parameter. When we talk of the radiation transducers, then we use the EM spectrum. The EM spectrum is where we have the visible light, the microwave, the radio wave, the short wave. So you can use any of those to do whatever you wanna do. And the rich variety of transit. Do you have these notes, or I am speaking French? On Mwere, I put there the section of notes. And on the section of notes, I put there lecture 1. And I'm on page 2. There are 14 pages. I'm jumping some steps. Or if you want me to start summarizing notes and start writing on board, I'll do that. But in this course, I'm trying to be as summarized as possible, because there are no hard things really. Maybe when I reach the capacitive and inductive, where we need to do a lot of stuff. The rich variety of transducers available for specialized spectral regions makes imperative some understanding of properties of radiation. So the correct transducer can be chosen for a given. Okay, how many of you have used microwave? How does it work? How does it work? Okay, you just put food, eh? If you put dry food, does it warm up? Like if you put a dry maize corn, this one's dry from the sun, will it cook?
You can fry peanuts there, but to keep regulating the section, until you fry the peanuts ready.
Okay, but are peanuts basically dry?
No.
If you ate peanuts, which even if they were dry, do you feel they are dry? The microwaves, their frequency, due to their short frequency, they make from solid state physics, they make the molecules of the water in your food to vibrate. And because of the vibration, then they heat up. That heat is what cooks. That's why they tell you don't put a metal. Because the metal, the molecules of the metal will heat up, and if you are not so keen, you find that the spoon probably has melted in the thing. But that's not the problem. The problem is that before it melts, you don't see it being hot, so you may want to pick your food. And it is very hot. Because even when you warm food, like and it is on a glass, on this ceramic plate, you find the whole plate is very hot. But when you look there, there's no big problem. So one time I made a joke, and some students really took me to be a bad man. I said that if I if I was the one punishing people, I would just put their hands in the microwave. You get cooked nicely. They don't even see any bruise. You get cooked very nicely. You are cooked completely. But I was just making a job. So measurement of ultraviolet radiation cannot be made if the transducer is contained in an envelope of window glass, or if the radiation must penetrate window glass to reach the transducer. Often the process of radiation transduction is linked to a particular source of radiation. It is essential that the transducer and the source be matched with regard to energy. Okay, so you cannot put a panel here and or make it face the board like this, and then you expect to receive or to produce any electricity. It must be able to be calibrated in the sense that you must make sure you put it at a place where it can be seen by the sunlight. Now, we start with the phototube so that I'm just going to summarize. If you get yes, what is it?
Make your body in window glass.
There?
The window glass.
There?
An explanation about the window glass. Window glass.
This one which is talked about here?
Yes.
The window glass is here, which is receiving ultraviolet light. So you can't just when you put a sensor here, remember the glass is transparent, but it can also reflect away there. So you won't receive the signal that you wanted. Exactly. So you have to make sure that you match your sensor. If it is a photo sensor, ultraviolet, a UV sensor, you must adjust it to make sure that the light is coming straight to your sensor. Otherwise, if you put your sensor inside here and you are expecting to get sunlight and everything, part of it has been reflected, like we shall see that from analysis. Part is transmitted, part is reflected. And so the transmitted one, there is one which is transmitted, one is reflected, another one is reflected. So you lose out on the quantity that you are trying to receive. So if your interest in measuring was to measure the radiance, the UV that you are receiving, then you have part of this UV that was coming being affected in these forms. Then you want to get the signal that you are expecting.
You're talking about the position of the
Okay, so if I was singing and I'm like, oh, I am putting the mic here and I'm singing, would I give the best sound? Oh, I'm eating the mic. There are these people who almost want to kiss the mic. Like, oh. So you hear the thing just making funny noise. So you must make sure your positioning of your sensor is appropriate, depending on the parameter that you are using to do the measurement.
Yes, that is okay. For a case of a microphone, it is understandable. But now for this, that is going to like this transducer that you're going to use to measure the ultraviolet. Okay. And then we have a window glass. Then position it. So it's a little better that you go outside and then you measure.
But you find if your sensor is not weatherproof. So that means you want to make sure that you want to measure the UV, but also your sensor is not weatherproof, so you want it to be in a safe place, or you don't want it to be stolen.
Yes, very good. And then you say, okay, you're not saying that is it. So part of the UV light will be reflected, some will be reflected, and some of it will be transmitted.
Depending on the placement.
Yes.
If I put a sensor on the window sill there, and me, like I have put it upright like this, assuming this is my sensor up here, and then I put it here, and I expect the UV to come and get it here, then I will lose. But if I could be able to put it in a positioning that it will be facing where if I want to get the sun as the sun goes around, and then I want to measure probably from, let's say, early morning when the sun has just come up and until when probably you are at the zenith, at midday. Then I can place it on the other side of the window so that it is able to. Now, if you look at our building from the same imagery, it looks like an aeroplane. With these ones being the behind wings, the front wings, and these other small houses. This other one here, and the other one here are like engines. And then the front one is like that. But that's not my point. My point is that if you look at our labs, you'll never get light in our labs. I think I said it when I was even teaching electricity and magnetics. You'll never get light in these labs here.
Light.
Sunlight. That you are doing an experiment and then sunlight is distorting your measurement. That's how smart those guys were. But these other ones where offices are, the light is able to go inside. And this side where the sunlight is coming from, they never put a window or a ventilator. The same applies to the other side of the building, but mostly the camp. But you go to schools. Someone has land, everything is okay, but they build a school, and when it just starts shining, the whole classroom is like you are outside. Then when it is about to be like the lecture theater was made like that to make sure that the light, the ambient light can be used even if there is no power. But then you know they put, much as we spoiled it, they put in this other room here, much as they put a veranda which can now cut off the light, but still they put these blinders, the dark things. But we Africans, we have spoiled it. So in construction, a person constructing should be able to know if it is a hotel, then the shades, the front and the back shade should be in the east-west, so that people can sunbathe in the morning and sunbathe in the evening. Someone wrote somewhere that actually the sunlight is good for if your bedroom is facing sunlight. I don't know the magic behind. I will do research. So, but I wouldn't want the sunlight to go into my bedroom. I would want to have my peace, sleep until when I want to wake up, and sleep whenever I want. Not that I'm being disturbed by the light. So, and if you, I don't know, I wish I could get any literature. These poles at the entrance here, those poles, I think they were having something peculiar. In July, the sun comes from this side. July has just ended, but now it is moving. It is almost in the middle there. In December, the sun will be coming from the top. If I'm at my office, the sun will be coming from the top of that other lab. In July, it will be disappeared. You wouldn't, because this is higher than the other one. Then I will be seeing nothing until when it is about August, September, November, then December it starts. Then it, because we are tilting like this. But some of you never really take, you don't note that one. I note it because of these things of moon view. I like the questions because it means that you are thinking. And that's what I want us to do in this course, thinking and making sure that we use the knowledge. So on, before I go any further, I saw 19 people. There are 21, but we are 2 other guys who are not students. So I saw 21 participants. Yeah. And who is, are you the Navas, okay. Chibuka. Now I have all the people who are there. So where are the other 5 to make 19? So we were thinking that we could do, much as I remembered again that some of you do Wednesday method, is it methods or what? EDE? You do it on Monday. So that means we can all structure to do practicals on a Wednesday.
Yes.
Much as it is inconveniencing for me. The reason is that if I was to teach in the morning on Monday, then we do practicals on in the afternoon, then Wednesday I would just be home and relax.
You can as well relax from this.
I use fuel every morning and evening. That's morning. If I save that fuel, I would be rich. I can't move from the moment I step out of the gate, I start burning money. Okay, the issue is, it's okay. So here is the deal. I had wanted to split you in groups thinking that I would have to cater for one group when they are doing it, then another group. So since you are all, because I want us to fix this. So we are all going to do the practicals on Wednesday. Anyone having an issue?
Yeah. On Wednesday, I have a class from 6 to 8.
What is 6 to 8? 6 to 8? Which language are you using?
Wednesday, I have a class.
6 to?
6 to 8.
6 to 8. Which 6? PM. And we should be done with practicals by 6. Will you be still doing practicals at 6? This is an instrumentation.
Depends the time I start.
2. The practicals have to start at 2. 2. We are doing, these are 2 practicals. We are doing 2 practicals on robots. So you come when you have already revised the parts of the robot, you come here, build it, it moves, then you make a report. And I see, I take a video of what you've done. So that's 1. 2, the other practicals are not, you did everything in electronics, so you are not going to have any struggle with either reading the multimeter or the oscilloscope. You are just 1. I'm being nice, but I could have said you're just 1, don't disturb us. Anyway, what I'm saying is, yeah, I could have said you suffer, we don't waste our time, go for another, I could have been around, like as you just go to another elective. No, I'm kidding, it's okay if it is from 6. By 6 to be done. I'm very sure. And if you are not done, there is a Monday, which is also, but remember, since Monday I will be here, and unfortunately, not unfortunately, that means if Monday, that means I could now make a electromagnetism course like another double like on a Monday afternoon. Another double, so that we finish early and we go at our pace. I really don't like the thing of rushing. I can just go on our pace so that I can make jokes, make stories, or you ask questions, and we finish early in a relaxed mode. But don't worry, we could just make sure we use that. So I had wanted to make, because these are 4 or 5 experiments. R1, R2, 19, 22, D4. There are 5. So those are 10 weeks. We are in the 3rd week, I think. And the whole thing is 14. So I had wanted to make them, if we do this Monday, we jump. And do the next Monday. But now that we are not in the, so when I talked to the technician, he said we can do only 1 day. And then they use the other day for preparing. Much as you have, you don't think you have that ED something for the whole afternoon. and then you have 6 to 7 for preparing, for going through your stuff. So I'm going to distribute you on a Wednesday, and since you are very few, how many were you in electronics? Each practical 2.
Yes.
So that means according to, if you end up being 20, divided by 5, that is 4. Doing practicals when you are 4 also is, but I think we can make more sets. Each of these experiments can have more sets. These ones at least they are if you are doing R1, if you are doing Explorer, you can have 2 sets. If you are doing Ride 401, you can also be, so that means 2 instead of 4 on each of the sets. I mean of the set. And if after this week, I will close the admission to this course. Anyone who is still looking at how things are going and wants to run away? Sekawa, we made an agreement that we can't go. He has to finish this course.
He was convinced.
Not convinced, he has to. If he doesn't, then he's in trouble. I make sure that the management becomes hard for him. No, I'm kidding. So, we shall, instead of alternating the weeks, we shall strictly use Wednesday. And that means Wednesday I have to be here by force. But then Monday I can finish and go home and sleep at 2. After I have eaten lunch, I can go and sleep. Then Wednesday I sleep, I come just to teach. Any other concern? These 2 guys, do you have any concern on Wednesday? Don't fear. This course, this is an elective. An elective is in a normal sense. This is a course that should give you a direction of what you want to, what you are passionate about. I know my experience shows that students do electives because they first ask who gives the marks. So X, Y, Z. Then they look for those ones. That's why I say that I don't need to convince you. You come or you don't come. So 4 of you. As one of the radiation transducers, you read the other one, the other stuff on your own. The phototube is a radiation transducer which uses the photoelectric effect. This is a radiation transducer that uses photoelectric effect. The device consists of a photocathode and anode enclosed in a glass tube. The device or the transducer consists of a cathode, or if you wanna be specific, you say photocathode. That is a cathode that produces electrons when the photons fall on it. So a photocathode and a anode. The anode doesn't need to be a photoanode because the anode is just to attract the electrons that are being produced when the photons fall on the cathode. But the cathode has to be a fluorocathode because it is producing electrons after being shone on by the photons. And a fluorocathode and anode. And an anode. So if you want, you say an anode or an anode. If I say anode, does that make sense? And an anode. So this is I like the way the thing was wired. Enough Africa. Africa is as long as something works, we have no problem. Quality, we don't care. As long as it works. Maybe it is not Africa, it is any mechanic. You find a mechanic of a vehicle, with his vehicle he just ties the bonnet just a bit and he's driving happily because it works. Then you find he's an electrician, his radio, the cover is just on the other side. The speakers are this side, and his plastic music is happy. Everything is just there. And he's an electrician, he should be fixing everything so that when you come you appreciate, but everything is just there. So one time I visited somebody and he's an electrical engineer. His radio, a very nice radio, was in pieces, but talking. So I'm like, why do you, he said, my friend, if you put it together nicely and looks like the thieves now want to take it. So you just put it there. And people maybe pretend, feel like this is crap. And so they don't bother you with it. So this is the fluorocathode and an anode enclosed in a glass vacuum tube. This is this glass here is a vacuum enclosed. This is not a photodiode, but this is an example of a vacuum tube. This one side doesn't matter because this is alternating current. The two of them can act as anode and cathode. And so you have the electrons being accelerated across. There was a gas which was closed in. It glows, but because of the fluorescent material on the sides, if I have a broken tube, maybe I'll come with it next time. I got it and broke a piece to show. When you scoop a bit of the inside of the tube, you feel there is like chalk, which is the fluorescent material. So it's the fluorescent material is the one which, actually if you cleaned it up, then you realize that those other tubes, these other ones which are fake, they do not give bright light. Because the fluorescent material there is not so good. If you cleaned up this tube, you wouldn't get any light. You just see a glowing glass molecules. I mean gas molecules which are not giving enough light. It's the fluorescent material that fluoresces. So this is enclosed in a glass vacuum tube. So when light falls on the cathode produces the electrons get attracted by the anode, and then current starts flowing. It is up to you to use that current for any output you want. If you put a buzzer is this like an alarm, like a siren. So if somebody came and opened the door, and you have put it that if somebody opens the door, even if he's opening it officially, but you didn't want people there. So you are not suffering with the door to be an alarm on the door, but when the light goes in the place, if that place was not supposed to be exposed to light, then it starts giving a siren. And then you know somebody, or you can use that to make sure that, like for example, you can say when it is in the morning, that's when my camera should start recording, for example, when I have a good picture. So it's up to you. It's up to you to find out the response to the signal. And why am I making a sensor? That's what I want you to understand, that you want to make an instrument, you want to make a gadget that senses something, you have to first think, what do I want to detect? When I detect it, when I get the stimulus, how should I, and it has created a response, how can I harness this response and be able to convert it into a signal? Is it electrical? Is it just mechanical? And if it is mechanical, can I translate the mechanicalness of it into an electrical signal? So for example, a weighing bridge, if a weighing bridge is supposed to be making sure that you measure how heavy a truck is, it is just a truck moving over that. So if it was to be the plates of the capacitor, then you can now utilize the capacitance. But then the capacitance is not so useful as in. So you can now draw the capacitance in the Q over V, and instead look at the voltage, which easily gives you the current that now can run something to give you a value. So for example, when you use a whole voltage, you know whole voltage? When you have a semiconductor piece, wafer or piece, and this semiconductor, you have a current connected to it, for example, by putting a battery across it, which battery is the one powering it, and then you make sure that you have a magnetic field. So this magnetic field will be in the blackboard. So if you connected this to power for the current being provided, then you would have the field in the board. You have this current here across this way, and the force would be upward. So you would have all the electrons. If the conventional current is in this direction, you have all the electrons moving in the other direction. And when you put these two variables, then they start drifting to the top. Then you end up having this one negatively charged, positively charged, then you get potential. And if you connected this wafer here to this other, to a voltmeter, somewhere here, you will get what we call the Hall. This Hall voltage depends on if this was the width, and this is the thickness, and then you have electrons. So I think it is VH would be equal to, is it net, is it net over what? It is medical. This is medical stuff. Did I put medical as references? Under references, which we agreed last time, I have put, that is electromagnetism. I have put all the textbooks there, which we are using it. Sorry, but all of you, apart from these two guys, others you are also doing electromagnetism. But this one here is used, for example, to measure the magnetic field within a given meridian. So this one here is now made in such a way that you get this part here to go into a place where there is a magnetic field, and then you read the Teslas. It is the whole voltage which is eventually bringing the whole stuff. But then the final results to read on the screen are the Teslas for the magnetic flux density. So I don't want you to cram, just cram then give me, but I want you to start thinking, and you you are like, okay, I want to make a fan which responds to, for example, clap. So then you need a sound sensor, which sound sensor you can now validate and make sure that when I clap, then it should be able to go on. And when I clap, it should go off. If I come in and I'm like, hello, then my lights go on. And then when I want to go, I say hello, then they go off. Because the first hello is to go on, and another hello will have to go off. Just like when you toggle on, if you open your phone and you want to play a radio, and you tap on the radio, the button will be red. You tap again, it becomes gray. Radio goes off. You tap, so if you tap accidentally twice, it went on and went off. And so you have to know those procedures and be able to know that, okay, if I do this, this will happen. But if this happens, I can make sure that I use the theory behind and make sure it is translated in the right sense of it. So you don't say it is a phototube, and then it is giving the electrons, and then you want to look for how to measure the electrons. You are not going to measure electrons. These electrons are going to constitute a current. When they constitute a current, can you make that current be able to be read in what you wanted it to give you? So you have to think hard. And that's why some people are getting a lot of, there are a lot of gadgets which are now being, I think somewhat now, like in a vehicle now, you can play music by having it on your phone or whatever gadget, whether your tablet or phone or computer, and then you play it on the speakers of the vehicle. So like if you are these people who go on a field trip and you want to show people a nice movie, you are not going to, if you have a projector, you are not going to struggle looking for a speaker. You just put your car there, open your boot, your subwoofer is there, and then, is it subwoofer or woofer? Your woofer is there, and then you connect the Bluetooth, the car BT, and then you start giving them a nice, like as if you are in a theater. Like when I was traveling on moon viewing, if I could bring my vehicle here, if it was possible, then I wouldn't be struggling to say, are you here in the sun? I just make sure that the sound is, So it's up to how you really try to make sure that you understand. And like I gave you the story of Turele. How many of you decided to actually listen to his story? No one. That's the challenge I normally have. That you see, the internet is free. There is free internet, free electricity, free water, free benches, free space. Even with the free chair I put for you. But you pretend there is no time. But you can narrate how the Arsenal match was. And this is not part of life. There is something some people said, and I found it strange, that when you are rich in a family, like when you are one of those people in the family and you are the one who is rich, you are always right. Whatever you say is right. They even laugh. When you are in a meeting and you are like, I don't think we need to do that. That one, I have sponsored it. Even, so no one argues with you. So how will Arsenal help you? You tell them, I know a lot of information about us and I know all the squad. But there are a bunch of guys who are really having a job by being commentators on radio, and that's they make a living from there. Others do the analysis I used to be here, like now I've started again, but I used to be here before COVID, almost even on Sundays and Saturdays, and even if it was Easter. So some guy came and he was like, hey, when do you rest? At least go watch some football. So I asked him, those guys who are playing football, are they at work or also at home? On Sunday or Saturday, those guys you go to see in Chibanda. And you're like, hey, he's about to score. Are they at home or they are in the office? The football pitch is their office. Ronaldo has all sorts of cars, but he's always in a pajama called Jazet. With all the suits that he can afford to buy, with all the nice shoes, polished shoes that he could buy, he's always in a pointed shoe which he can't even walk nicely, in a pajama and in something which is as short as here. If he's not on the training ground, he's actually on a pitch playing on a serious game. And for you, you are there, you have paid money, and even you are paying with your time watching and even analyzing. If he had passed there, I don't do that nonsense. I don't do that nonsense. That is wasted of my time. Because they are to work, I'm also supposed to be to work.
You know what replace?
The what?
You know what replace?
I didn't hear that, but I don't mind. But what? You said that I do what at my place?
Let's go for replace.
No. The football, I don't have time. Even now, I can't watch a full movie. But I listen on radio. Well, when that what?
At one point, you told us you cannot watch a full movie. What you always do, you go watch the highlights of the match.
And where are they? I go on a Manchester website. I know who scored, what time they scored, how many they scored, what position they were in the table. That's it.
How does it help you?
It helps me that when people are talking, I know who scored. That's it. So when they are talking, I say, but that guy scored late. That's it. I don't have time, but I don't even have those people who... But when I, let's say, go for repairing the vehicle, I just want fitting to make these people comfortable. So when they are talking, to make sure that they feel at home. Yes. But otherwise, if you go there and you pocket, and you are like as if you are calculating things, they are also calculating on how to cheat you. So for me, when I go to a shop, I don't speak English. Because when I speak English, they want to cheat me. So I speak Java, then they are like, then I ask what I want again. Then the moment I speak in English, I start speaking English, they are like, okay, but can't you also take this one? Then now they want to cheat me. Because of the... So this is the photocathode. This is the anode which is picking up. This is the cathode. And then we are having the light here falling here. The UV. So this is Planck's constant times nu gives you the... So that is the symbol of the... This is the electronic symbol. Electronic symbol. Am I too slow? A photo tube. So light is striking a large photocathode surface, transfers energy to the electrons in the metal, causing them to be ejected off. They are then attracted by the anode, which is held the voltage that is positive with respect to the cathode. The resultant current is directly related to the number of photons or intensity of the light that was striking the cathode surface, and the ease with which are ejected from the surface is related to the property of the metal known as its work function. That's where the H stuff comes about. And then you can plot the graphs which will be able to give you the light flux. Look at the characteristics of what you will get at the end of the day, so you will get those in the notes. I'm not going into that. So I'll just go to the forum, but I wish I could finish anything about this radiation. It's already 5. So today, those of you whom I talked yesterday, and some of you are like, no, is it yesterday or the other day? And some of you are like, he's bragging. So it is now 5:28, and we started maybe around 4:20. So more or less when I started that story or whatever was in that hour. And I wasn't even looking at the clock on the phone. So we look at the forum multiplier. The rest of the stuff on how it works, or just read this small part on where the notes on where I elaborate. So this one enhances the photo signal, the light signal. It multiplies the photons. By the time you reach the dynode like 4, you'll be having the thing having over multiplied now already for you. So a different kind of modification to the phototube permits high sensitivity with linear characteristics. And the schematic, so we look at the schematic, or we can say this is the improved, just to make sure, this is the improved, this is an improved version of the phototube that helps in the sensitivity, the sensitivity of the transducer. So we still have an anode somewhere, we still have the cathode, the photocathode, and then the whole thing. So we have a glass tube, forgive my drawing. So we have a photocathode still here. This is a photocathode. We have the light coming here, and then we start having the dynodes receiving the, so the dynode 1 will receive the electrons which have been ejected from the photocathode, and then it multiplies them. So it makes 2 of them. Then they hit on dynode 2. This is D2. D2 makes them 4. So it gets 2 here, another 2 here. So this is D3. EDC. So your tube can have as many as possible. finally we get the anode receiving at one point. And by the time it reaches the anode, you have a stronger signal. You no longer need to, you know very well that the signal also makes you, for example, if you are playing your radio on a place where the signal is low, you most likely do not get an efficient working of your radio. So you find you are tuning, the radio is struggling to get a signal, and at the end of the day you are overusing the batteries. And when FM came, if just a slight increase of the volume, the music is already blasting. Those days, our days, we were using shortwave. You have to turn the knob until so it depended on your skill. And as you have gotten it, the weather becomes funny, then you hear it. Things are going as you get the signal. And so you get that problem of the reception. But if you can enhance it, so that's why you will find that if you went to some localities, especially along the highways, you see some small, when you go to some of these slums, you find people with tall pieces of wood poles with those aluminum wound wires for enhancing the signal, to get as much signal as possible. So, and why not, if you understood how, for example, the antenna reception works, and then you can innovate a good antenna, which, for example, when you look at the idea of a dish, this concave, is it concave, or what is the other one? No, the parabolic. Is it parabolic? So it is a parabolic dish, the one whereby when anything comes from anywhere, in any form, from any side, eventually it gets concentrated on one spot. That's how the lamps of the vehicle work. Actually, when you look in the vehicle headlamps, you don't see the bulb. Actually, the bulb itself is covered with some metallic stuff. Because at the end of the day, when the light comes from the bulb and it hits the reflector, it goes, when you put food, when you change the light mode to food, those lights of the vehicle can go up to infinity. So if a vehicle is on a hill and it is in the point of sight and you are far away, you'll be able to see the vehicle is there, because they have this one is at the focal length. And it doesn't matter that you need light from the bulb itself. So some vehicles you find, almost all vehicles, you find that there is some metallic thing covering the bulb itself. And then all the light from the bulb goes to the reflector, which is parabolic, and then it goes to infinity, according to physics. Anything from the focal point is reflected to infinity. But when you put dim, there is another bulb, which now, whereby everything is reflected downwards to a short distance. But when you put full lights, they go. Now, let me brag a bit. When I was teaching this, when I had not started driving the vehicle, it was theory. I am just theorizing. I don't even know whether there is a dim or full light. You see where the problem is. That if you are not exposed, you teach, if you are a teacher, you teach to what you know, that's it. You've never entered a vehicle, you don't know even how to check I told you the story of how I prepared my thermostat. So now I know a thermostat. And I know how it looks like. It's just a small thing like this with a valve in there and with some adjusting thing here. So when you press the button for warming the vehicle, let's say if you put for drying the front glass or the hind shield, you hear it doing clicks. You hear something strange happening in that dashboard of the vehicle. You hear something there. So I was always wondering, what are those things moving? But it is just the other bit which is opening up now for the water. The warm water to go to if you have now chosen to start warming up the glasses. So as the warm water goes around, then it keeps reaching there and part of the heat is released to the glass. For the hind shield, it has the thermostat. No, not thermostat. It is, I've forgotten the name, I will tell you. But if you see those lines on the windshield or windscreen of the vehicle, these lines you see is a circuit for warming up the glass. Yes.
Yeah, because about this photo multiply. Okay, yeah, but okay, I've understood the context in which it is being explained. But however, okay, it is possible maybe like where is it applied in the daily life? Because when I try to follow your explanation, I think it is a transducer that is sensitive to visible light. But as you're trying to explain, you explain it in the context of radio waves and microwaves, the signals that we're talking about.
I talked about microwave since when
You talked about, okay, the signals for the TV dishes, the things.
I talked about this, for example, trying to show you how the small light of the bulb has been enhanced by the parabolic reflector. It's just light from a small bulb, but being received almost up to infinity. So I was just using it as a way of showing you how you have enhanced something when it was small. This is simply to multiply so that where you need sensitivity to any small light, you are able to get the signal, you are able to get the reaction. So for example, you want to make sure that any slight opening on if you, for example, had a greenhouse, and that green, or a dark room, like these days you don't process photos using a dark room. We had a dark room there, and some old man used to, I think he took my photos, but they were looking horrible. There used to be a camera and a whole set of machines. This place had a lot of stuff. I think most of the government staff has a lot of stuff, but even when you look at, for example, this table here, this is where they knew you would put things which are dirty because it is easily clean. You can wash it with water. But you know, we put the duster there and darten this whole place. And when the cleaner comes, also cleans with a wet whatever, but this is where it is supposed, it can be cleaned with anything because of the polishing. And you know how the other one in first year looks like. We don't know how to look after things because we don't know why they were made the way they were made. We don't even put an effort. I don't know whether it makes sense. They made this place so that they know, even this duster, if the board is well painted, I should soak this and rub with it when it is wet and still be able to write on the board in a few seconds. That's why I use those days I used to make sure I wet this one here, then I rub with it, and then the board is dark and looking nice. So it is, if you had a dark room and you want to make sure that any slight exposure to light should be detected, then you improve the phototube and now multiply the light. This light from the phototube, you are just immediately at D1 here, we had a number. So electrons would be generated here, anode would pick them, and then we get a signal. Now we want to make sure that even if it is just a small exposure of that, like if it is early morning when it is just becoming bright and you wanted the street lights to go off, then you can enhance that signal with the photodiode. If you wanted to make sure that when it's light it starts becoming darkish because of the rain about whatever, then you make sure that. So this is about sensitivity. But I used this other one here and the TV signals because that's what you are using to mostly. Each one of you at least watches the TV and listens to the radio. Yes?
I just want to understand. I didn't get that.
Which one?
The uses of these lines. I want to know.
The lines are, it's a heating element. The name is called you can Google for me. The name is, I think it is in the family of thermostats. But there is a nice name given to it. They even use them in winter places which are having winter. So in some of the path, they lay those conductors around, so they heat up. When current goes through them, they heat up, and then they warm the glass. Then that dew, which is always on the vehicle, dries up, or if it has been raining. Now, for you who may encounter issues with your vehicle, you get Colgate. This is not instrumentation. And smear on the mirrors, for example. And after it has dried for some time, it will scrap off. When you pour water there, they become water resistant. Water does not stick there. Like you can't find dew or such a. Well, but this one, because yes, some cars have they call it a selector something. Some people are even saying if a vehicle is the same brand but with the hind thing, it costs more. They have some wiper behind, but still these ones are also there for warming up behind the ship. They don't probably for cleaning if there has been a bunch of splash of the mud. But I am able to explain all these things because I have been interacting with the vehicle. Not everyone that has a vehicle and drives it also knows these things. There are people who drive a vehicle, it is theirs, but they have never known why those lines are there. You find somebody driving, the vehicle is new, the behind is just dark because there is a lot of dew early morning. Dew is there, he doesn't know you can press the button in front and that button for the behind sheet, then it warms up and once it has cleared, it goes off by itself. You find someone with their own nice music system, but because they don't know how to play around with the equalizer, they are listening as if they are listening from a small radio. And they are happy, they are good. And when they hear you bombing music, they are like, this man is crazy, why is he making noise? Just because they don't know how to use their gadgets. Are we comfortable? So we go to, this one, you will be able to find out that this is a modification of the photo tube, and when the photon strikes on the photodiode and the electrons have been released, the electrons get directed to another anode, which is a dynode by voltage difference. The first electron striking the dynode causes another two of them to be released, the two release four, the four release etc. And quite often, the physical placement of the dynodes and their shape are designed to control the gain within the photomultiplier tube. And the supply voltages necessary to accomplish this vary from about 600 to 3,000 volts. Well, so the rest you read on your own. I'm just trying to scratch a bit so that you... The next one is the photodiode. So it's a diode, a light emitting diode. It emits light when a current flows through it. This other one, it responds to the photons. So we have the photodiode. So a diode which is a PN junction is heat sensitive because thermal energy increases the carrier population, light is a form of energy, and the energy supplied to a PN junction affects the current carrier population. Sufficient energy must be supplied by light or radiation so that the electron can move from one band to the other. So I am not going to do much of that. So light emitting diode, we have the symbol. We have the diode, which we draw like this. We have our triangle, sleeping, and then we have this line here should be the same length as this line here. And this is a photodiode, meaning that it is responding to these photons. So this is the HB which we have. And then you know where if you don't put a lot of effort, the diode conducts in this direction. And if it is conducting in this direction, this will be from positive to negative. So then we say that automatically we know that this is the cathode and this is it like this or the reverse? The conventional current is moving in this direction. That's where conduction happens. So depending on once you have light shining on this diode, then it interferes with the carrier charges. Kauma, I know you are trying to say to look at and you are seeing the arrows which are like this. Doesn't matter, I could have known arrows coming straight like this, but I'm comfortable when the arrows are coming like this because they really show that they are shining. But in the notes, it is they are facing this direction like this, which I don't find very nice. So if the current is sufficiently large, the small, that is no right reverse current contribution to the total current can be neglected. Ordinary glass encapsulated silicon diodes are usually painted black externally to avoid the photodiode effect. So for successful operation, the photodiode must be reverse biased, and then the circuit symbol is there. I'm not going to write anything much about this. The forward bias and reverse bias issue is up to you. So the effects, the operation of the photodiode depends on the charge, the effect on the charge carriers due to the electrons produced by the photons, the exposure to the photons. I'm just summarizing. Then the reverse or forward bias is embedded in the word effect, and the rest is up to you to. So that is a diode that is affected by the photons. So then we look at a transistor which is also affected by the photons. So we look at the phototransistor. And you know that from electronics, a transistor is an arrangement of two diodes, either pointing towards each other or pointing out of each other. So they pointing towards each other, you get either PNP, or they point out towards, you have a NPN. if it is a bipolar junction transistor. So this is a logic extension of the photodiode, whereby the photodiode forms a base collector junction. So we have this junction here, and then we have this other side, up here. This should be a bit. And then we have the photons falling at this place, and then you get whatever you want. So this is a PNP or NPN?
NPN.
You have a base, you have a mirror, and you have a collector. So depending on this arrow, is it a PNP or NPN?
NPN.
NPN. Where does the current flow from to?
From positive to negative.
So it is NPN.
Yes.
So the phototransistor is an extension or a modification of the photodiode. And that is done by having a photodiode forming the base collector junction, where the photodiode forms the base collector junction here. This is, if you look closely, this is the part, the junction here. This part here is where we are having our photons around, forming the base collector junction. But we also have the base emitter junction, but our photodiode is placed at the. So you can see the essence of why we needed, or why you need to first do electronics and then eventually do instrumentation. Because now I don't have to explain the diode, the base, the junction, the depletion layer. You all know why a diode can emit light when there is dissociation of the charges across the junction. And why, when you switch off TV, the LED does not just disappear, it just goes slowly, because the electrons are now running back the holes and covering up. The holes which we take as positives are virtual, they are imaginary. When I'm walking forwards and I am leaving footsteps, and you concentrate your eyes on the footsteps, you feel like the footsteps are moving this side. But when for me I'm moving, so once that happens, the energy released is the light you see from a LED, the light emitting diode. Then when you switch off, the electrons come back. They come back to their footsteps, go covering up the walls. And it doesn't take, it is not instant. It is a process. So sometimes power may disappear, the image has disappeared on the screen, on the TV. Please don't say now I'm using TV. It is the easiest thing that most of you can see. And when the image is no longer on the screen, but you see that red light still lighting, and after some minute or 30 seconds, you say power has actually gone. I don't know how people who did physics, how they survive. You find a guy in a taxi without a belt, and when he sees a policeman, he just pulls it and just makes it lie here. Because he has no idea of the Newton's first law of motion. Did I tell you my story of how I got to love physics? So when I was young, we had this, well, the one I told you about, who was having that value, which was, looking fake. There are these vehicles of the electricity people. So the one of the drivers used to come and pick sand and bricks from our village, then to another next village. So I one time went and also tried to beg so that I can move away from our village and go beyond our village. So they put sand, and then for me, I went at the back here and stood here and even put these things here is where they put poles. If you have seen those vehicles of the moment, then it was UEB. But there were no poles, so I wanted to enjoy the swag behind. This guy was a rough driver. So he drove, then there was a cow crossing, so he slammed on the brakes. Even with the drag, due to the sinking into the sand, but I ran to the front. Before the guys who were in front, who knew the problems, because for them they were hanging on the front one, because they know his bad behavior. Before they could grab me, he sped again because the cow had gotten scared and gone back. So I went backward. And he was saved by these things. Then from that day, when we would be going to any other place, I would, these vehicles, it's an vehicle, I think most of the trucks, this brand, it has a compartment behind here. Some drivers even have their mattress and what, once you are tired, you just go there and sleep. These trucks which sleep. So this is where I used to sit behind the driver. I would ride there because it was a bad experience. But it made me understand Newton's first law. Me, I was still moving at the speed of the vehicle when the guy slammed the brakes to not hit the car. Me, I was canoeing.
Which class were you?
I was in probably senior like 2 or 1. I was pretty young. So from that day, it sank into my head that for me, I was still moving at the speed of the vehicle. He slammed the brakes, I continued. Then he started moving, I was still moving at the speed which was, now I had to go back. Now, from the time I bought the vehicle, before I start the engine, my belt is in. And I think whenever I overtake people, they think I'm crazy. But I've never felt anything. I feel I'm with my vehicle every time. And when I'm just like, maybe when I have just entered the compound and I'm trying to park properly and the belt is not there, sometimes you feel you are this way, the vehicle is this way. So I don't know how they drive without the belt. This taxi. You can't control a vehicle when you have no belt. Because you are struggling with the steering and the vehicle is on the other side. And for you are just struggling with it. Like you want to make a corner and you are just busy with the steer. And the vehicle is there. You are not part of the vehicle. So I don't know how they survive. They think they are bringing belts as a business, but it is to make sure that you counter the Newton's laws of motion. Just like this, the Baganda said nicely, if you knew anything about the equal and opposite reaction, that when a snake goes in your pot, you become stuck. If you want to kill it, you will break the pot. If you leave it, you may never eat if you hadn't cooked. Do you have ever heard of that saying? Yeah. This one now, you've never had the same sort of if you find that you can't harm this because the reaction, the consequences. It's like a mosquito being here, you're like, because you want to beat it hardly, then you hit yourself. If you have physics, if you have the third law in your mind, then you can't do that. And that's the essence of life. Do to others what you wish them to do unto you. That is for any action, there's an equal opposite. You do good to them, probably they will do good to you. If that so the photojunction of the transistor, that is the collector base, is reverse biased. The reverse current IC is due to the photodiode effect and would be proportional to whatever is being incident in that junction. So the rest of the diagrams and how this is combined is up to, and remember we did amplifiers. So you have a photodiode, you now can arrange your potential divider, and once you have put your potential divider, then you make an amplifier and amplify what was very tiny current which was produced by a photodiode, then you amplify it to huge experiment. Is it E7 or E4? And so you can, whatever you had put in as small, you make it large and then make it be felt at the output. So that's how all these stuffs come about. Then there is a photoconductivity cell. Photoconductivity cell. The photoconductivity cell or photoconductive cell is a semiconductor device whose conductivity or resistance changes when exposed to light. The materials used are the sulfides and the selenides of cadmium and lead, and me I'm almost just invested in the the circuit symbol, not photo symbol. The circuit symbol we have and then we have these bits, and then we have the incident light. So we know that light has a heating element in it. So when the light comes and has heat on this element here, if resistance increases, these two people and this one, where are you from?
We are going from space physics.
You are from a meeting? Where? Which meeting is that now? You are in MOOCs? You are meeting students, meeting the patron, meeting as executive, or?
As executive.
And you meet as executive during a test, a lecture?
Because now our members from different areas, so that is the time they suggested.
They also dodged over for them, they were free.
They also
And that was the convenient time.
because
You are a politician, you don't have to explain. But me, I'm just one. They dodged, but that was the convenient time. So it was convenient in which sense? You get the point?
It was urgent.
These ones dodged, the other ones dodged, but that was the only convenient time. So why couldn't you meet at like 8 p.m.?
some people don't see.
Where they can go up to midnight, it is allowed to move. You people are joking with knowledge. Me, I don't joke with knowledge. Every time I go in a workshop, I even use all the books they give me. I I write everything they say. I try to advise my children to write everything the teacher says, they refuse. That's their problem. I used to write everything that the teacher would say. I had a different book. I would get an exercise book and fold these papers like this, and then it becomes like a half book. So I would write on those, everything the teacher says. It's like as if I was a spy. Everything he says I would write. Even when he gives a story, I write the story. When I'm reading his story, I remember, he was explaining about the bell, electric bell, and then he gave a story of his second time, how they were. So I connect the two. I don't know, you advise somebody, I've failed to understand. You take an effort to give somebody these things that helped you go through, and then they are like, maybe, I think one kid was like, maybe the man wants to know whatever happens in your class. Why would I care? Whatever happens in your class. I want you to be able to know what is going on. There are teachers who are funny. They give an example in a funny way, but that's where they want to pass. And if you remember, either in electronics or in crystal magnetism, the things I would over-explain are the things I would bring. It may not apply to this. But the things which I over-explain and I feel I have made somebody understand, those are the things I would bring. And then people still fail. So I get frustrated. So the best operation of this device can be viewed as the process of electrons being freed by the radiant energy to move about the crystal structure, and then this decreasing the resistance of the material. Because when you interfere with the electrons are supposed to be moving once the current is flowing, the metal is able to connect because of, according to Brooks' model, once the electrons are able to move in a uniform direction. Now when you shine on the photons, and now you have disorganized the electrons, then the conduction becomes reduced, meaning that resistance has gone up. And once resistance has gone up, then, so either way, if light is on, resistance goes up, disorganizes the flow, and then you get problems with your flow of current. So you can use that to switch off, for example, the lights, the street lights, when it starts becoming morning. When it becomes evening, then they switch off. In the morning, they switch off. So you can use that properly. Instead of having to look for somebody who goes to the switch, turn it properly. Turn fully.
Make a full cycle.
This handle retracts the lever that sticks the other side. If it is still sticking there, it means you have not pulled it properly. So you have to turn it properly. I don't know. I am too particular. When I'm doing stuff, I am too particular. I want to understand. When I am doing some stuff, I try to make sure I understand why is it doing this way, why is it behaving this way. Last time this thing went off almost 30 minutes too. So I thought, I said, it is a problem because it may end up making my battery to get spoiled. But now, if I can keep the how do you call it in your language? If I can keep charging the power bank will continue trying to charge the camera. So I'll be able to finish my 3 hours still having current flowing comfortably. Before I got a power bank, remembered that I have a power bank, the camera used to go off, then I have to change the batteries. I think I did it a couple of times. I would come with 2 batteries, then during the change I would disrupt the recording. But this camera is good that it gives me one recording which is full. You have seen all the videos are now online. All our lectures. So I don't need, sooner or later, especially in electromagnetism, I will not be giving storage, so I don't have anything to remove. Because, and the ones on Mwere, they are not open to the people. They are under what we call unlisted. There is public, unlisted, and then private. So they are unlisted. It is me, it is only me when I give you the link that you can watch it. You can't search them on the internet and find them. I have already said what I said, so you have nothing to hear to start watching and listening to what I said. Another person would be hearing me abusing the president, probably, and then they say, here he's always abusing you. So I used to remove all those things in old videos. You wouldn't find those things, either a joke or like how I have now commented on this issue. I would remove all that. It was laborious. I've told, I'm tired, then I start removing those things, then I process. This one now does everything. So as long as it is powered on and up to the end, I have one video which is full. And then I go immediately plug the camera in the computer, then upload. And then online I can chop off the bits that I don't want in, which is also laborious, because I always talk many things within the middle, so I can't find out what I want. That's why I always talk in the middle after an hour, because then I know it is almost in the middle. That's where the adverts, the commercial breaks. Then I remove that bit. But like I've said, I've been able to understand how my things work. And that's why I make sure I teach such a course, because it makes me really want to inspire some of you also to be particular. Instead of teaching electromagnetism and we are just chopping la flesh. But this one, understand what is around you. You can't call somebody to fix a ball and you did physics. And you walk comfortably around the streets. But when the ball blew, then you call somebody, my ball blew. And then the guy steps on the stool, removes, puts the other one, and says it is now okay. Even if it is 1,000, it is gone. I told you of the story when our fence, you didn't find it nice. I have photos. This fence I used to cut it. So before I started cutting it, some fool used to cut it with a slasher. So one time I wanted to slap him. I went and asked him, why do you cut even, he would even cut like this. So you find the plants like this, and then with just small leaves like this. So I told him, never come back here. So I got some guy, I said, those ones were still good. I said, do you know who used to cut those things? He told me the man. The man had been changed to be a messenger, so he didn't want to do that work. So this young man said, but even if the other man doesn't want, I can do it. I said, how much? He said, 100K. I said, 100K, that is half of my fuel tank. So I said, okay, I will check on you. So I just went and picked my track suit, my boots. And I think for either 25 or 30, I bought the scissor. So on a Saturday, I would come very early morning, park, change to my track suit, boots, and work for 100K. And then I would sign a check, put here. People, colleagues would come, oh, IPFT, well done. I say, thank you. Me, I have my 100K. Afterwards, I go clean myself, relax, read emails, I drive home. I've been out, I have an outing, I've done gym, and my place looks nice. You know why? All of us, if I can use the word professors, we stay here longer than we stay in our homes. I leave my home, I don't even know how the compound looks like. I reach home when it is dark, and most people do that at this place. So You find somebody in an office with that covered chair, which is painful to the back. He has a nice sofa set at home. He has a big screen at home. We die frustrated because the stress you get in the office, and then you guys also come, you are talking nonsense, you are doing nonsense, you are failing the paper, so you find the man frustrated. But we are a professor. Your things are being enjoyed by house and those other people home. You reach home, even the big screen you can't watch. Before you start watching the barometer, you are sleeping. You are gone. So I chose to enjoy my life here. Soon I will invest in the flowers in the garden. Didn't I say that sometime? I made sure that my chair turns so that I have no back pain. And I said I will not rush home to watch TV, I'll be watching it from. So from 6:30 or so, when I reach here up to 8, I'm home, but I'm in the office. If it wasn't that they would report me that I have a bed in my office, I would also have a bed. So at lunchtime I can relax, but I may go to prison that I brought a bed for other wrong reasons. But I would have got a bed in my, and it is not just here. When you go to most offices around town, you find a man in a very dilapidated chair and a fake table. But when you go to his home, it's like you are in heaven. But when does he go home? And then our children also study in fake schools, with fake lavatories like these ones you have here. With everything is fake, but at home things are good. But at home they spend their 2 weeks in holiday. The rest, they are in. That's why we have people who don't have any sense of direction. Because you can imagine the club is more, I think, I normally watch things on Panorama, is it Pandora magazine on TV. I see club houses, those club places, looking nicer than even our lecture theatre. Cinemas in town look more better than the lecture theatre. When you are in the cinema hall, you want to even sleep there. When you are in our lecture hall theatre, where knowledge is performed, it is miserable. So, I don't know, where is the priority? But when you go abroad and you go in their lecture rooms, you want to be there. Everything, the guy just enters here, he doesn't need to carry the laptop like I'm carrying. He logs on to where, okay, they are e-learning system. After logging on, he presses the button, the screen pops down, the projector shines on, and he starts his stuff. Now you will be seeing all this stuff that I'm talking about, even if you don't have it on the phone. And if I was talking of Google, he Googles there when we all see it. We see all the applications of the multipliers. So where are we heading? But this time I have learned how to give myself peace. I no longer want to think of many things. These things were here. They were in much as some of you don't know that this thing works.
You still want to go to Canada?
Yes, I am investing. I'm investing in shares. I'm investing in so that I get money and build my sanctuary and leave you alone in your misery. Those of you who were not there last time, and those of you who came late, those of you who were there, these things were here. They were made to us in a workshop, and they stayed here without being used. Until when I said, we can't have nice things. And they got batteries and made them work. And started using them for most of the students I taught this course. So how many were not there last time? I don't know whether I have a marker here. So I created the line. It follows it. It has a nice, because it uses this light here to differentiate between the white and the dark part. You see even here at the edge it is differentiating between the edge, but of course it can't, whereas it's very, the edge now because of the light difference between this one and the dark one, it is able to, so you were not there last time. So this is one of the, this will be one of the robots to build. You have to build this one from scratch. They are just these pieces. These old pieces here come off. These are the pieces which have been holding the tire. Then these motors here, these servo motors will be removed. So all these bits, this is the brain of the thing, this one here. So this Buvera, I tried to really sort all the pieces, all these pieces here. All these pieces here. I sorted them into Buvera, but you are fake. I say you in plural, not you. You haven't done nothing. So that's why you will see that in some of the Buveras, you will find different things in here. They're not supposed to be different. They're supposed to be the same type. So that when you get a Cavera, they say pick 10 of these, you pick them, put them here. Then they say pick 5 of these, you put them here. And then you start constructing this. And then this line follower is a built-in. It's already built-in. The program is already in here. And you can program yours and make it do other things. This one is just following this line. You can tell it that when it follows it and it finds that if the line is thick, it can either use this side or this side. So it's up to you to choose what you want. But for now, we shall concentrate on this line. I drew it with the marker last time I was trying to demonstrate. Otherwise, it was not feeling anything. And if I had it, I don't know whether I put the marker here or whether I put it in, or I would have made another line so that you believe. So I will dismantle everything. After dismantling everything, that one, when it moves, or it will crumble it because of being heavy. I don't know what when you say I don't know what you want. The marker is here, so I can add more, just to make sure that you know what, when I say robots, some of you will say this guy is calling us that he's going to use robots. And you know, people are sharp. When some guy came here to watch the moon and he found me having robots, his daughter now has been in most of the countries participating in robotics challenges. This guy of Red Pepper, you remember him? The guy, the former CEO of Red Pepper, Rujen. I think he came here one time, or he read my stuff on social media about robots and whatever as part of the whatever. For him, he now, with the help of his child, he created, they call it something. I think they have a paid, if you have been watching on TV, they pay fees, then these kids go in a boot camp and then are taught how to build this thing. I think I will die poor sometimes because all the ideas I've been talking, others immediately look money, but I don't care about money. I have enough money. Money is enough depending on what you want to use it for. But like for me, I refuse now to eat meat, I don't eat chicken. So I eat the cheapest meal at the restaurant. So I save the rest of the money. These days I'm trying to make sure I don't take sugar, so that is saving. In the village, when you will be eating dodo, you know dodo? That is for the poor. Now in the city, you go to a restaurant and tell somebody to add you more dodo, they will abuse you. You tell the waitress that please add more dodo. They say that's enough. It is not enough. That's enough. In the village, it was that's for the poor. You know Morocco? This thing of the foot of the car.
Yeah.
Could you eat that thing in the village? How much is it here in the city? Even to get it where they cook it nicely. That's how life is. To get somewhere where they cook Morocco, you pay through the nose and you are not even sure whether it is well. Something which was trash, the feet of the cow you just throw away. So there's another place I saw where they make the heads of the goat and the cow. They also cook it. When we were young, I think one time we even bought a meal of the cow's skin. It is very nice.
Yes.
When you roast it and scrap off, there is a way it softens. I think people here, so who is the Muslim here? Forgive me, but these guys who eat the side mirrors, are they called side mirrors? Who eat the pig's ears? I think they are more or less eating like that's how the cow's the cow's skin is. I've just created this line. So it may not follow it very nicely, but so I've just written it.
So a bit correct in drawing lines in a real sense.
Pardon?
Like in a real life.
In the real life, you were not here, but in real life, you have what we call in precision agriculture. There is what we call precise agriculture, whereby you can plan your garden. Once you have planned your garden, if you are using GNSS, GNSS is Global Navigation Satellite System. Those of you who are doing space, you have an idea about it. So you can use antennas. You can use antennas to receive signals from the satellite and tell your robot, okay, your robot tractor, you tell it to do what at what point. Or you can make it physical and put a program and say, when you move 10 meters, you turn to the left, you turn again at 45 degrees, and then you start moving. And then you tell the blade to start cutting. For example, if you are making a mowing machine. And then after 10 meters, you say you turn and then start again slashing. So it is up to you to make sure, but this is the basics. These are basics, to give you the basics of how these robots are planned. The Explorer, maybe in the next lecture I would make it so that you see, but in the first, those of you who came late, we agreed that we shall be doing practicals only on Wednesday. And then Monday becomes free, and then Wednesday. I had even wanted to say Monday, then jump a Monday, another Monday, if we were to do 2 groups, so that you have time, because practicals are fewer, but this one is more, this one will finish the whole course. Even if we were to do this alone, it finishes the whole course. Because it is, for communication, it has a Bluetooth, you can make the two communicate. It has the connecting wires, it has sensors, all these are sensors. I told you of this is the man I made, and he turned just once. Like this. When he did like this, then the batteries were over. But I built it, I have a video. And so this man there and all these ones here are the sensors that we will be able to work on. These are all the sensors. So you have these are 2 touch sensors. This is servo motor. One of the motors, like these motors, are for the legs. You can use it for the tires. The Explorer will use it for the neck, and then you make it like this, and then where the tire would have been moving, the neck is the one which is moving, and then you have the ultrasonic sensor. One sends the signal, the other one receives it. So when the signal goes and has come back, then you can tell it what to do. For Explorer, which you saw in the video, if it finds that there is an obstacle here, then Where it doesn't find an obstacle is where it turns and goes. For the bumper, that video on YouTube. For the bumper, if it blocks the obstacle, the bumper hits on the touch sensor. Then the program says that you move behind a good distance so that when you turn, the bumper does not knock the obstacle. The mature of that is like the Curiosity Mars rover, which is on Mars, that is doing a lot of exploration. But this will be a small laboratory, a small bit. And then the light sensor here, we've just used it. And then there are others which are basically, this is the typical touch sensor. It has where you touch and then it locks, it sends the signal, just like a keyboard, the way you type and then the message goes on the other side. And there are a bunch of others. There is even this is the light sensor. And there should have been, there must be also, this is still a touch sensor. I really need to organize these things before you start using them. So that when you are using them, still touch sensor, then it can sort balls to blue, to red, depending on. There are many projects which you can do. This is the ultrasonic sensor. You just plug the communication cables here. They are like internet cables or telephone cables. I remember these are the other balls. They are green, red. There should be a sound sensor, but this is the microphone. This is the sound sensor. This is a sponge here for reducing so whatever transducer I've been talking about is embedded. This box here is able to finish the whole course, and then it will be done. But I still need you to remind yourselves of the electronics connecting stuff. So that will be the experiments. If you can follow, even if I haven't tried, but I remember them in the head. There is a D4, the E19, the E22, and then the R1 and R2, where R1 is robot. So R1 will be line follower, R2 will be the explorer, but then you can choose to build your own if you want. If you want time and you can get batteries, you can build your own. So these are 5. And then if we distribute them properly, that means we can have 2 sets for robots. Then the D4, I'm sure we can be able to have like 2 sets. E19, we also have 2 sets. E22, we can have 2 sets. And then that should be enough. And now that I see the number is almost being locked up, then I make sure, and once you are locked up, then I will make sure that all of you pass. Those people who refuse to come, so that we make them feel bad. Is it me to make you pass, or you are the ones to make yourself? That's why Capricorn is laughing. Well, I am the boss. I can choose you to fail or pass. I ask you hard things, you fail. If I consider everything that you have done and then average, you will make everything fake, then so that's where the problem is. I told somebody I will make the class fail, and the person thought I was very bad. I'm not bad. I can still make you fail professionally when I have not done anything wrong. We do 5 tests, I take all of them. I have not done any problem. So you find on average, each one of you gets 55. You got 7 here, you got 20 here, average. then I can make all of you pass. I choose the best, whether it is test 3, test 4, or whatever. Then I go to whether you do online assignments, I choose the best. So you all pass, and then you find them bragging, I got an A. They even look at me who did get an A in the course, and I'm the one who told you that they are like, man, got an A. So inside I'm like, do you know how the hell you got an A? That's how sometimes challenging it is to sometimes the decisions we do. I just want to check something. Okay, so I want to rush. Our time is, I didn't know that time can rush like this. So we have the, Margaret, what is it? So the best cooperation of this is that we've already said it is when we have the electrons being freed and then affecting the energy gap. And if the photon energy exceeds the work function phi of the meridian, the electron liberated from the solid is liberated from the solid by photoelectric effect. So it's all about the photoelectric idea. And then most photoconductive or photoconductivity materials have a short response time of the order of 10 to about 10 to 100 microseconds to incident radiation, because the excess carriers generated disappear very quickly due to the combination. The large differences in resistances under no light and light conditions, so I will not, that is your own, for your own consumption. So I go to the next one, which is a photovoltaic cell. I'm sure every one of you know solar energy. You hear of the solar panel. Some of you use calculators with a solar cell, but you don't really take interest in knowing. Most calculators have like a small part on the side. So when the bulb kaput, then and they are not connected. It is not that the solar cell is charging its battery, no. They have a battery component, but during the day, the calculator is basically working on the panel, in the solar cell. In the night, then you are using the dry cell that is implanted. And some actually may not work in the night, but when you put, even if you put turnover, how many of you know turnover? Kauma, you want to tell me you don't know turnover? That's the way you make your solar, those things I don't know. You don't know this thing which they craft, people craft, and it is like this, and then you have the frames there. Kauma, you've never seen that thing? This was it's a hand. Yes, with the hand. This one here, this is where you hold it. You grab it when they send it from the kitchen. Our kitchen was a separate place, then the main house. So they send you go holding like this, so that the wind does not blow it. It blows it, you go back. But for us, we had the more sophisticated technology. You pick one of the firewood piece, so you go doing like this. When you do like this, it glows. Then you see where you are going. So you go pick salt. Salt is in the corner, the other side. So you go. Then you pick. When you now you can walk freely. You came from far. For me, the life you may cause problems if you did it here in the city. Falls on a small piece, and then even if it fell on the sanitizer, then the whole house may blow. in whatever. But I don't regret having grown up in the village. There are things I did, and I think which made me understand a few things. And one thing that is funny is that thing I normally tell you about the diffraction of light. Our house we had changed, I think, the roof, repaired the roof. And when you repair, you cannot put the nails exactly where. Because at times you find that the beams, the trees, whether trees or whatever, the beams which are trees, were not timber, trees, eucalyptus. Timber is for you in the city. So you find that if it is crooked like this, where the hole was, you may never put another nail to have that spot inside. So that hole there, in the house we had some cracked part of the cement. And when the light, that white spot will shine, when it coincides with the crack, we know that is 12 p.m. Yes, we had the cement. At least the floor was, I told you that's where, you were not there last time. That's where I used to calculate numbers from. But the walls were mud walls. These, you put all, then you tie things, then put, but we used to paint it with this yellow thing. All the time and make it look nice. It's no longer there. I went there one time and I found they had removed it. So I don't have any souvenir to show people that our house is still there. I would have loved to go back and take a video of the diffracted, because it would be a small hole of the nail there, but down here it is a big white circle. Meaning that if the nail was this tiny and this thing is this big, that means light diffracted on the side. But you find a man teaching the thing who has never been in the village. He's talking about diffraction of light. Light bends around obstacles. How? Then our kitchen had a window which had no window there, and during the morning you are cooking, you are sweeping, and then you see these particles zigzagging around the Brownian motion.
Yes, Brownian.
And when someone is teaching, according to Brownian motion, the particles are having random motion. Where? But for us who knew that nonsense, okay, that is it is nonsense for some people. You know, being in the kitchen, I'm the one who used to cook for the others when they have gone to the garden. So they would prepare everything, then me I cook. After it is ready, I carry the whole saucepan to the garden. So that's how I was able to observe all these things. Yes, I would cook, and then when I reach there, I start breastfeeding. I told you I stopped breastfeeding when I was very old, until when I told my mother that. I said it is no longer tested. Because my brothers used to scare me. They say, "We the whole big person." I said, "Please leave me alone." And I told you, women should breastfeed their children until when they are tired. Because that is the only immunization you can give to your child. And children who breastfeed a lot, they are smart. These ones who go on formula, they can't hold anything in there, they are emotional, they don't know how to get attached to other people, and that's where the most problems are. So me, I enjoyed my life. Imagine telling your mother, "I'm done, it is no longer tested." And she was still willing to give me money. Then for a voltaic cell. I don't know whether I'm about to finish. There is a photovoltaic cell, then borometers and thermocouples, light emitting diodes, 7 segment, crystal, no problem. We shall be able to go fast next time. Because now I am trying to be casual to make sure that we set the ball rolling, and start doing business when that's my group. So I put a seal where we do our stuff so that by then we do the vowels for better for worse. For better for worse. So this is a solar panel, like this is a solar cell. This is a solar cell. I'm just using this word to make sure that this is a solar cell. That's the language of photovoltaic cell, and that's what people are now crazy about, PVs, photovoltaics. And this is just this is simply a diode, and this diode which responds to the photons, and then produces the current. And then you can use that current. You can multiply it by putting cells in series, and then produce a significant amount. And it only produces DC, and you can change this DC into AC by using an inverter, and then you use it appropriately for what you want. So we look at the symbol. Circuit symbol. So we would have this one here, and then we have the light falling on. And then you get the... So the photovoltaic cell is a semiconductor which converts radiant energy into voltage. Such devices are also called solar cells, since they are used to convert the sun's energy into electrical power. At the milliwatt power level, the device is useful in instrumentation. I've already told you that we can have a calculator which uses a solar cell. You can have a multimeter. Instead of putting in a battery, you have a solar, and you find that you can, wherever you are, you can be able to get what you want. So at the kilowatt level, an array of devices can be used for domestic power. If you have a module.
There's something that you explain very much in this stories.
Me, I wanted to explain it.
And then that's what I say.
The tado I used to get the way I wrote it.
The solar and then the solar.
Yeah. But I said that you could get a tado even on tado when you put your calculator there. It could still be able to go over. But I used to, first of all, using the science books. There were science books which had a lot of diagrams and demonstrations where they make you put razor blades in the cup, put on a can, put in water, then you produce a steam engine. In that book, they had told me that if you put light on the right-hand side, you get uncomfortable. But if your reading light is on the left, because we have two sides of the brain, we have the left brain and the right brain. According to either psychology or whatever, the right brain does not, I think, and if you really close, when you see things from the right-hand side, is not the way you interpret them when they are on the left. So I learned that I should put the tadova on the left. But also I innovated. I got a rim paper, made it round, and I would make sure that the tadova is inside there. So I would get a very romantic light for my reading. The smoke is going up there, the light is coming when it's all sieved out. You know, if you are looking at the tadova directly, it creates an image of the retina. So if you close the eyes, you see the flame, a dark thing on your retina. But when I would put the paper, even if I stare at the paper, nothing. There is no clear cut-out image on the retina. I enjoyed my life in secondary. If things are becoming tough in mathematics, I get my paper, I start drawing something. Once I stabilize, then I do chalk math. If I'm not in the mood of chalking math, okay, if I'm too fresh, then I read theory. I start reading the determination of capital G. I start cramming the transformer operation. These things of principle, they state the principle and operation of these DC and AC generator. That's how I got to understand them. When I'm fresh, I read them. When I'm not in the mood, I chop math. When the mood is too bad, I draw art. With fine art, I cannot doze. And when I'm finished my piece and it's looking nice, I start just appreciating it. And then I become fresh again. Please, go complete this. We shall look at the barometers and the other radiation sensors next time. But now we know where the notes are. And by next time, now I will be really doing the real stuff. I will no longer be introducing these things or whatever. We shall be doing the real stuff. And now that the camera has showed that my solution works, this one pretends to be charging, it still gives the power to this. My 3 hours are done, no problem. This one also, because I did not use the power for, last time I used the power for playing some videos, that's how I lost the power. So now we are in business. Can you tell that woman, is it a woman or a lady, not to delay you again? Yes. Tell her that we have a very stubborn physics lecturer. He says that keep your time. Nowadays, you know, if you tell her, he said that keep your time. Because he has only a triple to finish his course. And if symptoms persist, give her her number. I'll give her a call.
You know, these days, I'm the one in charge.
God, why are you laughing? She's very careful. She's a sister. She's a Catholic sister.
Sister to glory.
No. I don't think his sister would be able to do that. I'm sorry, I'm just, no. I'm just kidding. So, okay, so we meet on Thursday, but I'm going to organize myself and see how I first draft you on practicals. And please, those who haven't filled the Google form, kindly fill the Google form and upload your identity card. And then choose. Does it ask you to choose which day you want? Yes. There is no more choice of the day you want. We have agreed that we are going to do everything on Wednesday. And then Monday can always be, this lab can always be available for you to do whatever you want to do on your free time. Because I want you to learn how to solve the stuff on the PCB, that is a printed circuit board. I want you to finish this course and be able to do something for your life. And since I have DJ who does these things, because even the last time I taught this course, there was one student who was practical. He was repairing stuff. So now I also have this one who will be able to help you around and help me solve some of the parts, which I wouldn't. So, see you and have a good night.